بسم الله الرحمن الرحيم. السلام عليكم ورحمة الله تعالى وبركاته. Welcome to this video course. I am Dr Aouda Lakeb, Assistant Professor Class B, specializing in mathematics in the Department of Process Engineering, Faculty of Science and Technology, University of Ahmed Zabana Relizan, Algeria. In this video, I will present the second chapter of the Analysis 1 that I presented in the previous video, and this chapter on numerical sequences. This chapter is covered in 4.5 hours, and among its objectives are the following. First, determine the missing terms in a given sequence with a term-to-term rule. Second, solve more complex problems, such as generating a sequence or specific terms from a word problem in a real-world context, and which includes the following section: definition of numerical sequences, convergent and divergent sequences, comparison theorem, monotonic sequences, adjacent sequences, recursive sequences, and Cauchy sequences. In the following, we will focus on three fundamental concepts in numerical sequences, which are bounded sequences, convergent and monotonic sequences, and the relationship between them, and on the concept of adjacent sequences. Different phenomena in a various domains of science and technology can be represented through sequence. Moreover, a numerical sequence is an ordered list of a number that follow a specific pattern or rule. Each number in the sequence is called a term. There exist different types of numerical sequences between us: arithmetic and geometric sequences, quadratic sequence, and the Fibonacci sequence, which given by the following example. We start with the first concept, is a bounded sequence. For a sequence to be bounded, it must be bounded above and bounded below. So, a sequence is said to be bounded above if there exists a real number such that every term of this sequence is less than or equal to that number. And a sequence is said to be bounded below if there exists a real number such that every term of this sequence is greater than or equal to that number. Now we will give the following sequence defined for all natural numbers by the reciprocal of n. It's clear that each term of this sequence is strictly positive and is less than or equal to 1. So, we conclude that this sequence is bounded between 0 and 1. We will now consider the second concept, which is convergent sequence. A sequence is convergent to real number L, which means for all epsilon strictly positive, there exists a natural number n epsilon, such that if n is greater than or equal to n epsilon, implies the distance between un and L is less than 2 epsilon. And we write limit of un when n tends to plus infinity equal L. If the limit of the sequence does not exist or is equal to infinity, then this sequence is not convergent, it is divergent. Now we establish the first connection between bounded sequences and convergent sequences, which is further explained in the next theorem. If a sequence is a convergent, it must be bounded. However, the converse is not always true, as there are bounded sequences that are not convergent. An example of this is the following sequence. This sequence is bounded between -1 and 1, but is not convergent because its limit does not exist. We will consider the following example to prove that the sequence un is convergent to 2. So, for all natural number, we have the distance between un and 2 is equal to the reciprocal of n plus 1. We'll fix epsilon strictly positive, so the absolute value of un minus 2 less than 2 epsilon is equivalent to n is greater than to the reciprocal of epsilon minus 1. Then it is sufficient to choose n epsilon is equal to the floor of the reciprocal of epsilon. The next concept we will explore is that of a monotonic sequence. So we say that the sequence un is increasing if for all natural number the term with the index n plus 1 is greater than or equal the term with the index n. We say that the sequence is decreasing if all natural number the term with the index n plus 1 is less than or equal to the term with the index n. So a sequence is a monotonic if it is increasing or decreasing. Finally, we deduce the relationship between three concepts, and we have the following theorem. If the sequence un is increasing and bounded above, then this sequence is convergent. If the sequence un is decreasing and bounded below, so this sequence is also convergent. Now we will give the definition of adjacent sequences. So, two real sequences un and vn are called adjacent sequences if un is increasing, vn is decreasing, and the limit of un minus vn when n tends to plus infinity equal 0. If the two sequences un and vn are adjacent sequences, then they converge to the same limit. So we have the following example. These two sequences, two sequences un and vn are adjacent sequences. Why? Because un is increasing and vn is decreasing, and the limit of un minus vn when n tends to plus infinity equal 0. Finally, thank you for your attention.